Adding vector components using PhET. This video will show you how to add vectors using a PhET simulation. The other method you can use is trig. If you're familiar with things like SOHCAHTOA and are comfortable using trigonometry, you may want to go watch the other video. Otherwise, this video is for you. Hopefully you're familiar with what it looks like to add vectors from the previous video using the tip to tail method. In this section, we're going to be using a PhET program to add two vectors and find numerical values for the direction and the magnitude of the resultant. On your notes packet, there should be a link to the PhET simulation, or you can search PhET vector addition. The purpose of vector addition for this unit is to deal with forces that act in both the x and y directions. So we're going to want to go to Explore 2D. I like having the values and angles checked to make it easier to read what we're trying to find. In the problem, we're wanting to add vector A that's positive 8 newtons in the vertical direction, or up, and vector B that's positive 6 newtons in the horizontal direction, or to the right. Okay, so let's go to the simulation. I'm going to want to add in vector A. That was 8 newtons up, so I'm going to want to make that 8 boxes up. It doesn't matter where you place this. You can place this at any point on the grid. Just make sure you have space to add in the other vector. So I'm also going to have to add something to the right, so I'll make sure that I have space to the right. Vector B we said was 6 newtons to the right. So I'm going to add in vector B, make that 6 boxes to the right. And this is really important. What you need to do is add it tip to tail. So what I'm going to want to do is put the tail of the second vector at the tip of the first vector like this. All right, now we can find the resultant. So I'm going to add in vector C. And what I want to do is I want to put that where the first vector started and make that end where the second vector ends. Okay, so here it shows the magnitude of that vector that's shown as absolute value. Absolute value is a way to express magnitude. And so the magnitude of this is 10. And then also it has the direction, sort of hard to see on the grid here, but you can also see that is 53.1 degrees as measured from the positive x-axis. Okay, so now that I've got the direction and magnitude of my resultant, let's go ahead and enter the work. So if I go back to the packet, it's probably useful to at least show your work by sketching arrows. And so you can go to the line tool and select arrows to show the direction of the vectors that you added and how you did that to make sure that you're doing it tip to tail. So I had one vector that was up. And this may be kind of hard to see, so what I'm going to do is make it a little bit bigger and maybe also change the color. So that represented my vector A that was up, and then let's do another arrow to the right representing my second vector. And then my resultant, I went from the beginning of the first vector to the end of the second vector. There wasn't really any math or scale conversions to do this, but what I found was that my magnitude was 10, and the units of these were newtons, and my direction, what was my direction? Let's go back, 53.1 degrees. By the way, to see this up at the top, you do need to have the C vector selected. Otherwise, it'll show the other vectors. So 53.1 degrees was my direction. 0.1 degrees. Okay, and that's our first example. So let's go ahead and take a look at the second example now. So the second example, I've got vector A that's negative 9 newtons in the horizontal direction, and vector B that's 5 newtons in the vertical direction. All right, so I'll go back to the simulation. To get rid of the arrows and start over, what you're going to want to do is click this eraser down here. So the first one, vector A, was negative 9 newtons in the horizontal direction, which is left. So I'm going to want to drag in A. And let's make that 9 to the left. Again, doesn't really matter where you place it, but let's make sure we have room to go up 5 for vector B. Okay, so vector B is going to be 5 up. And again, the important part, tip to tail. So I'm going to want to put the tail of this one at the tip of the first one. And then now what I'm going to do is I'm going to add in my resultant. And again, that goes from where I started my first vector to where I ended my second vector. And here we see magnitude 10.3, angle 150.9. I'll go ahead and put that in. So I had my first vector going to the left. Make it a little bigger so you can see it. My second vector going up. And my resultant going up and left. By the way, that should make sense. If I've got something going to the left, then something going up, my resultant should be going to the left and up. So you can always use that as a double check. And what we said was the magnitude, let's just double check, 10.3, and the angle, the direction was 150.9 degrees. 10.3 newtons for the magnitude. Direction was 150.9 degrees.